Hey guys, I hope you all are doing good. In this lecture, we will be understanding the weak induction, right? So how to do a proof by weak induction. This is going to be a very important type of proof, and this is usually the most difficult to understand. But we will be covering a very good examples, and I'll make sure that you understand in detail of how the proof by induction works, right? So let's try to read the statement, right? What is proof by induction? It is a mathematical technique used to prove that a statement holds for numbers in a certain domain. Example, it could be natural numbers or it could be integers. So just to give you a basic idea, right, how we understand whether I'm supposed to prove this by induction, what what you'll get is, or what kind of proof statement you'll get is that we are supposed to prove something for set of all numbers, right? So maybe prove some equation that it is true for all the natural numbers or maybe for all integers. And the way this proof works is that we kind of create a domino effect. So if you remember, if you understand what is domino effect, if I drop the first domino, if I have a big bunch of dominoes, right? If I drop the first one, then it will create a flow and all the dominoes will keep dropping down, right? So this is kind of like this. What in general, in very simple summary, what we do is we prove something for a single number and then we prove it for the next one, and this creates a logical flow, which basically we don't have to prove it for all the different numbers in a certain set. It creates a domino effect that we have, since we have proved this for this certain number, then it is true for the next one and the next one, and hence it is true for all the numbers that exist in that set, right? If you're not able to understand what I'm trying to say, that's totally fine. I think the things will become a lot more clear when we look at the examples, right? But now let's try to understand what is the structure of weak induction. So just like I said, just keep in your mind that we are trying to create a domino effect, and you'll understand how we are trying to do it. So let's look at the structure, right? To prove, this is just a basic example, to prove for all n greater than equal to n0, Pn is true. So this can be a general form of the proof that we have, right? So over here, let's say n is such some number, and this n0 means first element, right? So what we are trying to do is there's some certain first element, and we are trying to prove that for all the numbers greater than it, some statement Pn is true, right? It could be an equation. For example, for all numbers, we are trying to prove n plus 1 by 2 is equal to 3, right? Just an example. This is not true in general, but I'm just trying to give you an example that it could be that we are trying to prove for all the numbers which are greater than some certain number. This is the equation, right? So so we get certain type of equation to prove for all numbers n Pn is true. These are the following steps, right? It's very important to understand that if you're not, what usually happens sometimes is we're not able to solve a proof by induction question, but it is very important to remember all the steps in your mind, right? Okay, so let's try to understand with the first one. Verify Pn not is true. That is the first element is true. So the very first thing I do is, right, think about it in a domino way. If I have all the dominoes, the first thing that I verify is if my first domino is in the right position, right? If I verify that, in this case, what I'm trying to do is I'm trying to prove that the first element, that the statement is true for the first element in the set, right? It is usually, what usually happens is that the set is the natural numbers or the positive integers, right? And since both these sets have a certain least value, for example, for natural numbers, it is 0 in computer science, and for positive integers, it's going to be 1, right? So in that case, we are supposed to prove, for example, if the set is natural numbers, then I'll try to prove it for P of 0 and then try to continue ahead, right? So verify Pn is true, where Pn, the n0 is going to be the first element. When I first proved that it is true for the first element, then we go ahead and write down the inductive hypothesis, right? Now, this is the important step. So we make the assumption that Pk holds for some k greater than equal to n0. Now what I make the assumption is that for some value k, the entire statement Pk holds, right? I'm making this assumption. Now, what I'm trying to assume is that for all the numbers which are greater than equal to n, I'm making the assumption that this Pk holds. Now, I know this might sound kind of very crazy or very difficult to understand, but this part is the next part is where we use the domino effect. So currently what we did is we solved the first one, we made the proof that it is true for the first element, right? That the statement is true for the first element. In the next one, we assume that pk holds for some k greater than equal to n. Think about it this way, right? We have made the proof that all the dominoes that we have placed are equally placed and they have the right distance between them, right? Now, in the next step, which is the third step, we show that pk, which is, if we assume that pk is true, then it implies that pk plus 1 is true, right? Now, what I'm trying to do is that I'm trying to prove that if this set is true, then the next one also has to be true. And this is where the domino effect plays, right? So think about it, right? If I'm saying pk is true, then this implies that pk plus 1 is true, which further would imply p k plus 2 is true, right? And this will create a domino effect, which will basically create until the very end, which will go until the very end. And finally, we can have the conclusion that by induction, it holds for all the numbers in our set, right? Let's try to understand this once again. So the first thing is, this is the domino effect, right? First thing I do is I prove the statement for the very first element in my set, right? If it's integers, positive integers, then it is going to be 1. If it's natural numbers, then it is going to be 0, right? The next thing is I assume that the statement holds for pk, right? For all the numbers where k is greater than equal to n0, which is the smallest element. Okay. The next thing I do is, in the third step, I'm supposed to prove that if pk is true, right? If it's true for all the numbers greater than equal to n, then it has to be that pk plus 1 is also going to be true, right? And if I prove this case, then that is where I've created the domino effect, proving that the statement pn holds for all the numbers, right? Okay. Don't worry if you're not able to understand what I've explained right now. I probably made a very bad explanation, but I hope you are able to understand the steps, right? The base case, the inductive hypothesis, showing this, and finally reaching down the conclusion, right? So everything happens in these 4 steps. Now let's take a look at 2 different examples in which we will solve using the weak induction. Once again, this is going to be weak induction. In the next lecture, we will be understanding what is proved by strong induction, right? Okay. Okay, now let's try to make this proof using the weak induction, right? So what we're supposed to do is we're supposed to prove the sum of first n integers is equal to n plus 1 by 2, right? So what usually, this is actually a true statement. So basically, if you try to read the statement, right, what I'm saying is 1 plus 2 plus 3 plus, if we go until a certain number n, then the proof is that it is the sum is equal to n plus 1 divided by the value 2, right? So just a basic example, if I consider 1 plus 2, it is going to be equal to 2, 2 plus 1 divided by 2. So if this is 3, then this is actually 2 multiplied by 3, which is 6 divided by 2, which is equal to 3, right? So let's try to understand how this works, right? We're supposed to prove it, and we are going to do this using the weak induction. Just like I said, there's a general understanding about if I'm supposed to solve a question by weak induction or strong induction, right? We get a certain set of numbers and we are supposed to prove that statement for that entire set, right? So let's try to solve and let's try to take a look at the first case. Just like I said, we're supposed to look at the first, which is the base case, right? In the base case, we solve the question for the first element of the set. Now, if it's been given in the question that the first element is n is greater than equal to 1, hence the first element is going to be 1, right? Okay, so base case, show P of 1 is true, right? I'm going to show P of 1 is true. So let's put it into the equation, right? 1 is equal to 1, 1 plus 1 divided by 2, which is equal to 1 multiplied by 2 by 2, and this gives me 1. So using this equation, I've proved that the base case is true. That is, this equation is true for the very first element of the set, right? If you try, just to give you a visualization, this is kind of like I have set up the first domino in the correct place, right? Okay, next thing is, now I'm supposed to find, give the inductive hypothesis. So I'm going to make the assumption that it is true for all the elements, that this statement is true for all the numbers k which are greater than or equal to this value n, right? So this step is kind of like setting up all the other dominoes that you have. So I set up the first domino, which is the base case. In the second step, I'm setting up all the other dominoes that I have, right? So in this case, gives me the fact that let's assume P of k is true for all k greater than or equal to 1, right? Okay, I made the assumption, which is what I'm trying to say is that 1 plus 2 plus 3 plus until some value k is equal to k plus 1 by 2, right? This is the assumption that I'm making, that if pk is what I'm trying to prove, then this has to be the equation corresponding to it, right? So I've just written down the equation corresponding. Okay, so this is the inductive hypothesis that I have, right? Which is basically I'm going from the element 1, which is the first element, until the k, right? And since this is the original equation, then for the value which is at the end k, it has to be that k plus 1 divided by 2 is the value for this equation, right? Okay. So let's assume pk is true for all k greater than or equal to 1. So I hope you understand the inductive hypothesis. Okay. Now, let's try to understand the third step, which is the most important one in this case, right? Which is the inductive step. Okay. Now, in the inductive step, what I'm supposed to do is I'm supposed to prove that the statement is true for all the values k plus 1, right? So if we are supposed to do, if pk is true, then it implies that pk plus 1 is also true, right? So let's try to do that. So let's prove pk implies pk plus 1, right? Okay. Now, what would be the representation of this equation, right? If I try to write it down, then pk plus 1 would simply be 1 plus 2 plus 3 plus, towards the end, there would be a value k, right, which is going to be the second last element, plus k plus 1, which is equal to, right? Okay. So just a quick example, right? This is going to be the left hand side of the equation. And what am I supposed to prove in this case, right? I'm supposed to prove p of k plus 1 is true. And if you think about it, then p of k plus 1 is actually k plus 1, k plus 2 divided by 2. So what I'm basically supposed to do is I'm supposed to take this left hand side and reach this point, right? This is how I can say that p of k plus 1 is also true, right? Okay. So if you look at this equation, right, on the left hand side, maybe I can replace this 1 to the value k with this equation that I have, right? So if I replace this part with this equation, what I get is I get k plus 1 divided by 2, right? This is the value that I get, and plus I also get k plus 1. This is the value that I get. Remember what I'm supposed to do, right? I'm supposed to show that this is equal to this point. Now, it might seem very tricky to understand, right? Look, the basic point is that I'm making the assumption P of k is true. And using this assumption, I'm supposed to prove that this is true, right? That is why I'm only using the left hand side of the equation and not the right hand side, right? Okay. If I had assumed P of k plus 1 is true, then I could have represented the entire equation with this on the right hand side. So, okay, moving on, let's try to understand. I have this point. I'm going to take 2 in common, which gives me k plus 1 plus 2 multiplied by k plus 1, right? Now, if you think about it, this kind of seems like the distribution law, right? Where I have k plus 1 and k plus 2. So this results in k plus 1 multiplied by k plus 2 divided by 2. And think about it, right? This is the point that we were trying to reach. This is exactly the same as this equation. So this is what we were trying to prove, and we have reached this point using just the assumption that pk is true, right? And hence I can say finally the conclusion is p of n is true, right? Okay, just to give you guys a quick summary, right? This is just like the domino effect, right? So first thing is we were supposed to prove that for all the values, the sum of all the values from 1 till some number n, it is equal to this equation, right? Which is n plus 1 divided by 2. So I'm supposed to solve this using the proof by induction. The first assumption that I made is um, first is the base case, right? So I proved that it is actually true for the base case. So it's kind of like I set up the first domino in my entire project. Second thing is I'm supposed to do the inductive hypothesis, which is I made the assumption that let's say pk is true for all the values which are k greater than equal to 1. So let's say that there is this equation and it exists for all the numbers which are greater than equal to 1, right? Now, might seem very intuitive, or how can we assume simply for all the numbers? But this is exactly how it works. But the most important part is that in the next step, am supposed to prove that if I assume pk is true, then it also implies that p of k plus 1 is true, right? This is the step where it creates a domino effect, making it true for all the values that we have in the set, right? So I made the assumption pk is true, which gives me this equation. And using this pk, right, I'm trying to prove that pk plus 1 is true. And since the value comes out to be k plus 1, k plus 2 by 2, this is actually equal to this equation, right, which is basically this equation that we are trying to prove. So I hope you were able to understand this question. Now I'll be giving a bunch of practice questions for you guys to solve. Okay, so given only two questions on the board. First one is prove that 4n minus 1 is divisible by 3 for all n greater than equal to 1, right? And the second one is the second one is very close to the example that we solved. But once again, um, we are supposed to follow some basic steps, right? Which is first the base case, then the inductive hypothesis, which is assume that it is true for all the values k. Then, using that assumption that it is true for all the values k, we try to prove that it is true for all the values k plus 1, right? Yeah. And when we reach this point where we have proved that it is true for k plus 1, then we have reached the final part, right? Which is we have reached the conclusion part. So I hope you would be able to solve these questions. But if you feel like you're not able to understand it, I will also post explanations for these two questions as well, right? But for now, I'll put the answers in the description. So in the next video, we will try to cover the strong induction in detail.